Different types of solutions for a linear system, or the properties of a system involving two linear equations. One solution. Graph the following system on the grid to the right. Y equals 2x minus 7. Minus 7 and 2x. Oh, let's pick a color. So up 2 over 1. And let's get lots of points. Can't go down. Okay, let's draw the line. Y equals 2x minus 7. And how about red? Y equals negative 2x plus 1. Negative 2 down 2, right? Down 2, down 2, down 2, right 1. Up and left, up, line. Make sure I'm in a good place on the tablet. Let's go line this way. Back to the pen, red. And we get y equals negative 2x plus 1. If the two lines intersect at only one point, which these guys do, then there is one solution to the system of the equations. The solution to this system, ordered pair, that's 2, negative 3. The only criteria for a linear system to have one solution is that the lines have, what is it? They're different. Lines have different slopes. Because if you have the same slope, you're parallel. So no solution. Graph the following system on the grid to the left. Y equals 1/2 x minus 3. 1/2. Go up 1, right, 2, up, 2, up, 2, down, and over. And here's a line. There's the line. Arrows. And label this is y equals 1/2 x minus 3. 1/2 x plus 4. 1/2. 1 over 2. 1 over 2. Down, 1 left, 2. Let's draw this line. Now, what kind of lines are these? Well, we know because they have the same slope. These lines are parallel lines. If the two lines do not intersect, okay, so parallel lines won't intersect. They're not going to cross each other. So then there is no solution to the system. The criteria for a linear system to have no solution is that the line, the lines have the same slopes, which means the lines are parallel. But not just the same slope. They must also have different y-intercepts, because what happens if the slope and the intercept are the same? Graph the following lines. Do they use that? Let's go back to purple. y equals x minus 2. So negative 2. Y equals x. That's 1, right? A slope of 1. Up 1 over 1. Down to the left, 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 down to the left. Draw a line. You got it. Oops. Dang. I think I can move this slightly. There we go. You got to draw the line somewhere. And arrows. And graph line 3y equals 3x minus 6. What should we do? Red? This one might be pretty easy to do with intercepts, right? So the y-intercept, set x to 0, we get 3y is negative 6, so the y-intercept is negative 2. And if we set this to 0, then we'll get 3x equals positive 6, which means that's 2. And those 2 points, when I draw a line that goes through those 2 points, it's the same line. It's the line I already have. So if the two lines are the same line, we actually have another fancy word for that. It's coincident. Coincident. Then there are, well, every point on one line is on the other, so there are infinitely many solutions. Criteria for a linear system to have infinitely many solutions is lines have the same slope and the same y-intercept. I don't think that needs to be plural. Coincident. Overlapping lines coincide with each other. In other words, all the points that define one of the lines also exist on the other line. In a system of two linear equations, if the lines intersect at one point, then there is one solution. If the lines are parallel, then there is no solution. And if the lines are coincident, then there are infinitely many solutions. Okay? Examples. Complete function. If two lines intersect at only one point, then the corresponding system has one solution, and we know that the slopes of the two lines are different. That's all we need. Different slopes, only one point of intersection. If two lines are parallel, the corresponding system has no solution. The slope of the two lines are the same, or the slopes, and the y-intercepts are different. So same slope, different y-intercept. You have two different lines, parallel lines, and no solution. If two lines are coincident, then the corresponding system has infinitely many. The slopes and the y-intercepts of the two lines are the same. So if you know the slope and the y-intercept of both lines of a linear system, so what is it you need to know? Slopes, because if they're different, one solution. If they're the same and the y-intercepts are different, then there is no solution. And if they're the same and the y-intercepts are the same, then there are infinitely many solutions. So if you know the slopes and the y-intercepts of both lines, then you will know how many solutions there are. One of the equations of a linear system y is y equals negative 3x plus 5. write a system so the resulting system has one solution. Y equals 2x minus 7. Basically anything but negative 3x. No solution. Got to be parallel, so negative 3x, but different intercepts, so minus 3. The intercepts are the same. Infinitely many solutions. Now don't just write the same line. Go with 2y is negative 6x plus 10. Basically any multiple of this will give you a coincident line, right? It is the same line. So don't just repeat this line down here. Give it in a different form. 4 equations are stated below. State the slope and y-intercept. So the slope is 4 and the y-intercept is 7. The slope is 1/2. The y-intercept occurs when x is 0, so make that 0. 1/2 of 2 is 1, and then add 6. And you don't want an y there, you want an m. So m equals 1/2, and b is equal to 7. Okay, so if you put 0 in for x, 0 plus 2 is 2, half of 2 is 1, and then you add 6 to both sides. A little bit of work here, so the 4y. 4y is 2x, so 4y, move that over, minus 12. Y is equal to 1/2 x minus 6, so we divide by 4, oops, and that'll be a 3. 1/2 x minus 3. So the slope is 1/2. Y-intercept is negative 3. What do we got? 2y is 8x plus 14. Y is equal to 4x plus 7. Slope is 4. Y-intercept is 7. Choose 2 of the equations to make a system such that there's one solution. Alright, one solution. So A and B would have one solution. A and B. Or A and C. Or B and D. Okay, so lots of ways. No solution. Well, the only one that has no solution would be B and C. They need, because they have the same slope and different y-intercepts, and infinitely many solutions. The only one with that is A and D. Okay, so one solution. What else? We got A and B. It could have been A and C. Could have been C and A. We've got that. C and D. And it could have been B and D. Solve the system of equations below algebraically. Equation 1, equation 2. Let's go 2 times 1. So we get the 4x's. So we get 4x plus 6y is equal to 18. And here we've got 4x minus 5y is negative 4. I can subtract 4 minus 4. 6 minus negative 5 is 11y. 18 minus negative 4 is 18 plus 4, which is 22. So y is 2. Substitute back into, so 2x plus 3 times 2 is 9. 2x plus 6 is 9. 2x is 3. And x is 3 halves. So our solution is 3 halves, comma 2. We can check that. So left side is 2x plus 3y. Right side is 9, so that's 9. 2 times 3 halves plus 3 times 2. 2's cancel is 3 plus 6, which is 9. And the left side is 4x minus 5y. The right side is negative 4. Two within 4 twice, so we get 6 minus 10, which is negative 4, so that checks. So we have a solution to the system, and there's 1 point, and that solution verifies. Solve the system of equations algebraically. Give an explanation for your answer. So let's move this over so it becomes 3y is equal to 2x minus 9. So y is 2/3 x minus 3. And from this equation, y is 2/3 x minus 2. These are parallel lines. Since they have the same slope. And different y-intercepts. Okay, so parallel lines, and there's our explanation. We don't want to try and solve this. If we did, we would get no solution. And we get some statement that didn't make any sense. Solve the system algebraically. So let's multiply this by 2. 8x minus 10y equals 40. And let's rearrange this. 8x minus 10y equals 40. Since these are the same equation, or alternatively, I mean, we could have gone 5y is equal to 4x minus 20 and got y is 4/5 x minus 4, and we would have got the same thing there if we had gone through and divided by 10. We would have got 8/10, which is 4/5, and minus 40 over 10, which is 4. So since these are the same equation, they are coincident lines. And have infinitely many solutions. Right, so basically any point that satisfied this equation would also satisfy that equation. And there are infinitely many points on any line. Determine the number of solutions. So determine, show some work here. So let's take that first one. It's going to be 4y is equal to 2x plus 1. Y is 2/4 x plus 1/4. Y is 1/2 x plus 1/4. And let's take this. So 6y is equal to 3x minus 2. Y is equal to 3/6 x minus 2/6. Y is equal to 1/2 x minus 1/3. This has no solutions, right? Because these lines are parallel. Y equals 3x plus 20. This will be y equals negative 3x plus 20. This is 3x plus 20. These have one solution, right? Different slopes. Different slopes. Okay, let's multiply by 4. It's going to give me 2x minus y equals 5, or y equals 2x minus 5. Move that over and that over. And multiplying by 6 gives me 2x minus y equals 5. And actually, they're the same line, right? But we could rearrange this. So these are the same line, same slope, same y-intercept, and has infinitely many, finitely many solutions. State the value of k such that the system below has no solution. No solution means same slope and different intercepts. So if they have the same slope, then k is equal to 3. That's why this is a state. There's no real work to show. They have different intercepts, same slope, no solution. Algebraically determined. So there's got to be some work to be shown here. The value of k such system has infinitely many solutions. Infinitely many means I need the same equation. So let's rewrite this as 2y equals 5x plus 4. Now, to get from 2 to 6, I'm going to multiply by 3. And that'll give me 6y is equal to 15x plus 12. So k is equal to 15, making these lines the same and giving infinitely many solutions. Right, so therefore k equals 15 gives us coincident lines. Algebraically determine the value of k such that the system below has no solution. Okay, what do we need for no solution? We need parallel lines, right? What do we need for parallel lines? Same slope, different y-intercept. Okay, so let's get this into slope. So ky will be negative 3x plus 6. Y is equal to negative 3 over kx plus 6 over k. And here it'll be 8y is equal to 12x plus 5. So y is equal to 12 over 8x plus 5 over 8. Y is equal to 4/3, right? Wait a sec, no, divide by 4. This will be 3/2. Cleaning up. 3/2 x plus 5 over 8. So, parallel lines, same slope. That means that negative 3 over k must be equal to 3 over 2. Negative 6 is equal to 3k, so k is negative 2. And 6 divided by negative 2 would be negative 3, and that's 5/8, so they'd be different, right? So same slopes, negative 3 divided by negative 2 is 3/2, so we would have the same slope, different y-intercepts, and therefore have no solution. And we're done. That is it for systems of equations.